I'm going to talk about what's new in cross-compilation. Who's interested in cross-compilation? Really? Okay. This is about GHCs, right? So if you want other cross-compilation, I can't help you today. This is me. I used to work in mobile and desktop apps, and I have this blog where I wrote a lot about cross-compilation. So if you're interested, there's like lots of information on there. And I have these 3 Twitter handles. The noise level is mostly at the first one and least at the end. The mobile Haskell stuff will probably tweet about new releases of new binary releases of GHC cross compilers if you're interested. The ZW3RK tech stuff will be mostly posts that I post on Medium and maybe retweet whatever mobile Haskell posted. So in case you're interested, just follow them on. Okay. So my ultimate goal is if you compile GHC, you basically go ahead and say configure, provide the proper target, make install, and you have a proper cross compiler. That works mostly with GHC head right now, but one large thing that doesn't work is binary distributions. We'll come to that later. And also I want the template Haskell works, because if you say I have GHC, but anything that uses template Haskell you can't use, anything that uses transitively template Haskell somewhere in the dependencies you can't use, that's to me that's kind of pointless. So I wanted that to work, and I want to have an easy option to provide a final binary library you can just link with your binary. Yes?
Within scope support multiple targets, or like,
okay, so the question is about multi-target support.
Yes.
I've talked to Simon and Marlo about that. Ideally, we'll have that. It will take some time. So there's like lots of plumbing that needs to happen all across GHC package, and other tools to even make that happen. For now, it's not. So you'll have a bunch of different compilers, but you can all install them all side by side. So that kind of make things easier. And yeah, okay. So template Haskell. Initially that didn't work. It was always this statement that if you want to do cross-compilation, template Haskell is basically a no-go unless you do this evil splicer stuff. I talked about that 2 years or a bit more when I was here, which basically says, okay, I have a splice, so it dumps the splice, then compiles it on your build machine, and then tries to resplice it back in. That is pretty ugly. So for template Haskell, around last December, ShareLevy started lifting most of the ifdef blocks around the GHC IMAC defines in GHC, which basically prevented any of the template Haskell code paths. So most of them are now available, but the next roadblock was there was no linker. So what happens is when you compile template Haskell, the splice usually calls some function or some other action, and what GHC needs to do is have a way to execute this function. So you kind of need to compile that function, link it, and run it. That's why you need the linker, and that's also why cross-compiling is a bit harder. So in GHC.js, which I guess most of you know, they have template Haskell support. And in GHC.js it works by having your compiler, and whenever it sees a template Haskell splice, it ships it out to a runner process. The runner process, it runs on your JavaScript machine and evaluates the splice and sends the result back, and then the compiler continues with the result of the splice. And the same idea was so Simon Marlowe basically found that idea pretty great and implemented iServe, but iServe currently only allows to run the external interpreter on the same machine because it uses file handles to communicate. Which, if you want to do cross-compiling on a machine like the phone that's over there, I don't really have file handles there. So now we have iServe Remote, which you can kind of install on your device. And then there's the iServe proxy, which basically provides GHC with the file handles, and on the other side, a network interface. And with all that, you can kind of compile template Haskell and cross-compile it to whatever you want. And yeah, most of this is documented on the blog. And I want to note, yeah, Obsidian Systems poured some money into doing that. Static libraries. So usually when you compile GHC, you get a bunch of object files, and they're scattered all over the place. And then you have dependencies in packages that you depend on. And if you want to have everything in one package, you kind of need to pull all the packages together and then link them together. GHC had static lib for a while, but that only worked for Darwin platforms. So basically, iOS was the only, I think, that was actively using that. And that worked by abusing the lib tool on macOS, which is a bit different than the lib tool on Linux. And I kind of got fed up with it and wanted to have that for general availability. So I wrote an archiver which can archive GNU and BSD archives, and you can basically use static lib with GHC head and produce a static library of all the dependencies in one static archive, and then use that for linking. Next thing, we have the LLVM backend. The LLVM backend has this great, it generates textual intermediate representation. LLVM understands two intermediate representations. One is the textual, and the other is a binary form of the textual one. But the binary one doesn't change that often, so it's much more stable. And the current LLVM backend we have tries to be a very good consumer of the CMM it's fed. And to do that, it kind of erases all the types it knows about and turns every symbol it sees into an int8 pointer. And whenever it needs to call a symbol, it calls it, it casts it as needed to the right type. This makes it quite hard to get that strip right, because in GHC we have functions, and on top of these functions we have the so-called info tables. Now, if the info tables would get stripped away, your function is basically useless. And we work around this in GHC by providing an alternative entry point to the function. This works as long as you only call as long as you only call Haskell code, because then you always call directly the function name. If you call C code, you basically end up in a kind of wrapper, and then LLVM doesn't see anymore that you need the info table to the Haskell function and strips away the info table. So that's why that strip doesn't work on our current code, and that strip is only relevant for macOS, so it's macOS and iOS and all those. The LLVM NG backend works around that by not trying to have to cast any time, and it tries to know the types always, and that's why that strip works with that. It doesn't have support for metadata, so we can't do TBAA, and it doesn't have support for function level symbol tails, which means whenever you disassemble the intermediate representation you get from this, you basically, if you look at the function, you would like to see that this is like the argument names you gave the function, but what you see is not 1, 2, 3, 4, 5 is just a sequence. So that would be nice to have. So next, a hackage overlay. I know who has heard of the head hackage overlay? Not many? Okay. So probably 2 months ago, Herbert Valerio Riedel posted to the GHC dev mailing list that he had this head hackage overlay, which means whenever you take GHC head today and compile it, probably any package you try to compile will break, because we have this semigroup monoid proposal which is currently implemented, and the head hackage overlay provides patches on top of packages that are in hackage. So to you it's transparent, but it will patch those packages as needed for GHC head. So you can just use GHC head, use the head hackage overlay, and it usually works for all packages that are patched. And that sounded pretty interesting for the cross-compilation case, because for cross-compilation we can't use custom setups. So any package that uses a custom setup in the Cabal file will not work for cross-compilation, because you can't compile the setup and run it on the device. There's basically no logic in Cabal. And there are also a few other issues that might arise when trying to cross-compile code to mobile. And that's why I have this experimental mobile Haskell hackage overlay. There's only one package currently in there. It's the libz package that is patched. And you'll also find on the same side, you'll find the pre-built binaries for macOS Sierra and Debian 8 compatible Linux systems. And those compilers will use by default the LLVM NG backend, just in case you're wondering. So for cross-compilation, we need our toolchain wrappers. Why toolchain wrappers? Usually you have your Android NDK, and then all those tools are somewhere deep down in the path is hidden. And for iOS, it's even different because you basically want to run the XC run command and give it the proper SDK and then the tool, and it should look that up. And the toolchain wrappers basically provide you with like lots of aliases that have the target triple and then the program name. So you basically have ARC64, Apple iOS GHC, and LD and runlib and GHC. And that way you have kind of a unified interface of all your tools. It even has your target triple plus the cabal, and that does stuff like feeding HSC to HS, the cross-compile flag and all that. So you don't need to care that much about the rest anymore. Now, installing cross-compilers is not as easy as I would like it to be. You'll need the LLVM5, and you'll need also the toolchain wrappers. And I would have hoped that you could just configure, point it to the prefix you wanted it, and then make install, but that doesn't work because the binary distribution that GHC builds is not really engineered towards building cross-compilers as binary distributions. So whenever you run configure, it basically redetects your host, redetects your build system, redetects your target, and those will all end up like the local machine you currently have. And by that, it completely screws up all your defines. And for cross-compilers, you basically want a fixed set. You know your toolchain, you just don't want to change anything, and that just doesn't work so well. So I've spent quite a bit of time working on the new GHC build system, shaking up GHC, now called Hadrian. Maybe anyone has heard of it, to make it produce relocatable GHC binaries distribution. So you can basically just zip up the bin and lib folder and then just move that around. So that should make that a lot easier. But to make that easier, there was some very nice person, Christian, who created this GHC, this cross GHC script. So you can just use that script, and it will download them properly, configure them properly, and install them for you. So you don't need to care so much about that breakage. Okay, if you have a cross compiler now, assuming you have it on your system and you want to compile anything, of course you can use Cabal, but maybe that's for another talk because there's lots of stuff that's interesting there. So you basically have your GHC. You say you want a static lib. You give it a name you want your static lib to have, and then you give basically all the modules you want to compile, and that produces that static lib. You need to make sure that you have some FFI export somewhere because you need some way to call your GHC code. Then you link your target application with that binary, that archive you just created, and all you need to do then in your application is call hsinit and then the exported function from the exported FFI function you have. Okay, and that concludes my talk.
How about for Raspberry Pi?
For Raspberry Pi, I think the target is ARM, Linux, GNU ABI. Yeah. There's also binary distribution for Raspberry Pi. The thing for Raspberry Pi is you need the Raspberry Pi SDK. So there's no official Raspberry Pi SDK, so you need to create one. It's not that hard. It's also documented on the posts I made. I was considering maybe uploading a Raspberry Pi SDK, but that kind of depends a lot on which date I'm creating the SDK, because whenever you basically run get upgrade on your Raspberry Pi, all the files and libraries and whatever might change.
When you say SDK, you mean PIO port better, right? Like if I just program.
If you don't want to link anything and don't need any headers of the Raspberry Pi, you don't need the SDK. If you need any of the headers or want to link any Raspberry Pi library that is on your Raspberry Pi, you need the SDK. Similar to what if you have the Android SDK, it contains all the headers, it contains all the libraries to link again.
Those are libraries, right?
No. If you want to do file I/O and all that. This is the Bionic stuff that's all in Android. So you need those headers if you want to use those functions. If you don't want to use those functions, you don't need the headers.
What about for Raspberry Pi?
Yeah, if you just want to depend on libc, that's okay. But if you want to depend on anything else that ships with your Raspberry Pi. So what are we talking about? Just the CPU, or do we talk about all that comes with your Raspberry Pi and Raspbian and whatever you have installed on there? because if you're talking about, okay, maybe I should have made that clear. I was talking about the Raspbian SDK, not the Raspberry Pi SDK. So if you want to use anything that's in your Raspbian installation, you kind of need to have an option to include those headers and link against those libraries. So you need this SDK which contains all those informations. Okay. Other questions?
Is that something you could put on?
What?
I
This?
This? A thing that runs only on Raspbian.
You can, in theory, install a completely different operating system on your Raspberry Pi.
But yeah, so I mean, if you make a thing that only works on one distribution on Pi, doesn't work on other OSs?
That's pretty much like building binaries on Linux. That's also not guaranteed to be. Yes?
That's fine, because I love it. Raspberry Pi, you have.
Yes. Yeah.
So wouldn't you just link any library the same way as?
Yes. But you still need the headers, right?
Right. But, I mean, okay, but then SDK is the same thing on your normal, right? So the -dev.
Yes, kind of. It's just packaged up. For example, I don't have any of those packages on my Mac. So I kind of need like this virtual Linux header set of headers, and they need to correspond to the installation on my Raspberry Pi. Of course, if you run Raspbian on your Raspberry Pi and run a similar enough Linux on your desktop, you could just get away with using the same headers. You might get into issues once it starts getting into word sizes and all that, but yes. Yes. Okay. Any other questions? Okay.